Okay, this is May 2008, question 5. In this question we're given two boxes, box A which has a mass of 4 kilograms and box B which has a mass of 5 kilograms. There is a force forward here of 135 newtons. The two boxes are connected by a wire and there is a force due in that direction of 9 newtons, and we're asked to calculate the tension in the wire. Now, whenever you're given a system with two objects which are connected in a straight line, then the first thing to calculate is the acceleration, and we do that by considering the whole system as one big mass. So we can consider this to be a big mass of 9 kilograms. And that is subject to a forwards force of 135 newtons and a force that way of 9 newtons. So clearly the direction the object will move in is that way, because this is bigger than that. So I can put my double arrow to indicate acceleration and put A. Notice we're not worried about the tension in the wire now, because we're considering this as one single object. And so this tension is really, it's an internal force within that mass, so we don't need to worry about it. And so applying F equals ma gives us 135 minus 9 equals m, which is 9 times A. And if we solve that, that gives us an answer for A of 14 meters per second. Now we've calculated the acceleration, we can move on to do what the question asked, which is to calculate the tension in the wire joining the boxes. Now clearly, as this force pulls forwards, this wire is trying to hold this block back, so we're going to have the tension acting that way. On the other hand, from the perspective of this box, it's being pulled forwards by this wire, so that's going to act that way. So we can see now that if we look, for example, simply at just one part of the system, and I'm going to look at this part of the system, rather than this part, because then T is forward, which means it's positive. If I'd looked at this part, T would be backwards, which would mean I'd have minus T in my equation. So I'm going to look at this bit, and if I now apply F equals ma to this part, then I've got T, so applying F equals ma, T minus 9 equals 4 times the acceleration 14. F equals ma. And if I solve that, that gives me my answer of T is equal to 65 newtons. Okay? And that's the end of question 5.